Hello everybody, welcome again to my channel. For this video we're going to be considering Riccati's equation. I want to say a big thank you to the person that requested this video. I really want to appreciate it. It means that you are following my videos and it's actually giving me drive to continue. Thank you very much. So we're going to be considering Riccati's equation. To do this, we would first of all consider the standard form of Riccati equation and show that it is reducible to a Bernoulli equation, and a Bernoulli equation is reducible to a linear equation after which we solve. I'll just write the standard form of each of these equations and then solve a problem. Okay, as easy as that. So the standard form of a Riccati equation is y prime plus px y is equal to qx plus rx y squared. So Riccati is just saying that if you have a function of x multiplying y, you have a function of x multiplying y squared, okay, and there is another function of x standing alone with your derivative also in an equation, that equation is a Riccati's equation. Okay, so before we move to solving example, let's also take the standard form of a Bernoulli equation. Bernoulli's equation is of the form y prime as the first derivative of y plus pxy is equals to qx y raised to power n. Observe, this is raised to power n. Okay, if you observe a Bernoulli's equation, you notice that there is no function of x, f of x, standing on its own. There is nothing like that. You don't have a function of x standing on its own. So you cannot say that a Riccati's equation is a Bernoulli's equation yet. So there are 3 steps to solving a Riccati's equation. Okay, the first step is look at your Riccati's equation, put it in standard form. Take some steps which I'll be explaining soon to change the equation to a Bernoulli's equation, after which you will now take some other steps to change it to a linear equation, and linear equations are quite easy to solve. I know I've not introduced this in my channel before, but this is like a quick video to just answer a question. I will possibly take time out to explain each of these equations, solving each of these equations in subsequent videos. Okay, this is just a quick video to explain Riccati's equation. So the next step, I will just want to show you what a linear equation looks like. Standard form of a first order linear equation. All we've been talking about is first order. Riccati's equation is first order, Bernoulli's equation is first order, and this linear equation is obviously going to be first order. So the linear equation is of the form y prime plus px times y is equals to what? Function of x alone. Let's call it q of x. So for now, I just want to make something like a table showing the 3 different equations general standard form, so that you can see them clearly before we take a problem to solve. So type of equation and then standard form. So let's start with Riccati. So what can you remember about Riccati? Riccati is just saying what? Y prime plus pxy, okay, is equals to some function of x alone plus one function of x times y raised to power 2. Bernoulli is just saying what? Y prime plus p of x y is equal to q of x times y raised to power n. Remember, Bernoulli does not have what? This. So what doesn't have a function of x standing alone. So what makes Riccati equation not yet a Bernoulli equation is this function of x standing alone. And even this function of x standing alone is not there, then we have exactly Bernoulli's equation where n is what? 2. I just wanted to observe that. Okay, The next one is first order linear equation, and I said that this is of the form what? Y prime plus px y is equal to some function of x alone. So this is the step from Riccati to Bernoulli, from Bernoulli to linear. Moving forward, we need to know how do we change Riccati to Bernoulli and how do we change Bernoulli to linear. Riccati to Bernoulli. For Riccatti's equation, most of the time you'll be given a particular solution, one particular solution, say y1. Okay, just know that. But even if you are not given that y1, you can by inspection look at your equation and say, oh, if I put y to be this, I think that this will happen and this will happen. You just use your foresight to guess one y1. It's usually easy to guess, okay? But most of the time you'll be given your y1, so don't worry about that. So recall, Riccatti's equation is of the form y prime plus p of x y equals q of x plus r of x y squared. Okay, what you need to do is use that y1. So given y1 as a solution, you need to use this y1. Okay, how do you use it? Pick a dummy variable. You can pick w, you can pick z, you can pick v, something that you can use as a variable. Okay, and say that let z be equal to y minus y1. Just notice that z is also a function of x. Okay, so if you say this means that what y is equal to z, I'm adding y1 to both sides, z plus y1. Okay, this means that what dy by dx, I'm differentiating this, okay, is equal to dz by dx. I told you that z is a function of x, that's why it's not 0, plus, I know y1 is also a function of x. Okay, so dy1 by dx. This is enough. Go ahead, substitute this into your equation. Anywhere you see dy by dx, which is y prime, you substitute it into that place. Okay, and anywhere you see y, you substitute this whole thing. So you see y here and you see y here, so you substitute them into that equation. So moving forward, when we get a Bernoulli's equation, how do we convert to linear equation? Very important question. So what do you use? So pick any dummy variable in your mind. Any dummy variable. You can pick v, you can pick w, but don't pick z again. That one you picked for your Riccatti's equation, you cannot pick it again. Okay, so you just pick what you did not pick before. So I'm going to pick w now. I'm going to let w to be equal to y raised to power 1 minus n. Okay, this is Bernoulli's work. I don't know what inspired him to pick this particular thing to substitute, but it really works. Okay, just have it in mind. Anytime you see a Bernoulli's equation, just substitute w is equals to y raised to power 1 minus n. So your n is actually your greatest power of y. Okay, moving forward, when you do this, you get your dw by dx is equal to, I'm differentiating this with respect to x. Remember that y is a function of x. Okay, so you differentiate it using function of function. Okay, so this is, I'll differentiate this normally and then differentiate this alone, okay, with respect to x. So this will give me 1, keep this, 1 minus n times y raised to power 1 minus n minus 1, which will give me what? Minus n. Then I can differentiate y with respect to x. That will give me the y by dx. If you make the y by dx the subject of formula, you have dy by dx is equals to, you're dividing through by this, okay, y raised to power, we have 1 over 1 minus n. I divided through by this first part, you have 1 over that. Dividing through by this, the minus will go, so you have y raised to power n dw by dx. So anywhere I see dy by dx in my Bernoulli equation, I put this, and anywhere I see y, you just raise both sides to the power of 1 over 1 minus n. Remember, if you have y squared and you want to remove this squared, you multiply it by what? 1 over 2. I would raise both sides to what? 1 over 1 minus n. So w raised to power 1 over 1 minus n is equal to y. So I'll substitute this and I'll substitute this. Okay, so let's solve x cubed y prime, right, plus x squared y minus y raised to power 2 is equal to 2x raised to power 4, where y1 is equal to x raised to power 4. If you try to substitute y1 here, you see that it will actually solve this problem. You can take that and do it yourself. But for now, let's find out if this is a Riccati equation. In my mind, I know it's a Riccati, but let me show you. So this is a function of x multiplying y prime. So we have that at one side. The next thing I need is what? A function of x multiplying y. Do I have it? Yes, I have it. Even if I don't have it, there's no problem, okay? But I can keep checking, okay? I have it, right? Good. The next thing I check is I need a function of x multiplying y squared. Look at this. This is minus 1. This is minus 1 times y squared. That's what it is. Minus 1 is a function of x, a constant function. Okay? So I can take it as a function of x. And then I have a function of x standing alone. See, it is this function of x standing alone that makes this equation not Bernoulli, but Riccati. Okay? So I would try to put in the standard form of Riccati equation. What do I have? I have x cubed y prime plus x squared y is equal to, what do I have? A function of x alone first. 2 x raised to power 4 plus y squared. So I just took this to the side. That's all. Alright. And we see that this is what? Riccati. We have a Riccati equation. So how do we solve this Riccati equation? We need to substitute what? Z is equals to y minus y1. y1 is what? Y minus x squared. y1 is x squared. So we need two things. We need dy by dx and we need what? Y. So make y the subject of formula and from then get dy by dx. So making y the subject of formula, we have what? Y is equal to, so I'll take this to the side. Negative becomes positive, okay? So z plus x squared. Now I'm going to differentiate this. This implies that what? Dy by dx. Remember, z is a function of x. You can see it easily because there's x squared here. So z is a function of x. So this is equal to what? Dz by dx plus, if I differentiate x squared direct to x, I have 2x. Now I'm going to be substituting this into the equation. X cubed dy by dx plus x squared y minus y squared is equal to 2x raised to power 4. So anywhere I see the y by dx, I'll put this, and anywhere I see y, I'll put this. Okay, so that gives us x cubed dz by dx plus 2x plus x squared. I'm seeing y now, so I substitute z plus x squared minus y squared is what? Z plus x squared all squared is equal to 2x raised to power 4. Divide through by x raised to power 3. We have dz by dx plus 2x plus x squared divided by x cubed is what? Just 1 over x. Okay, so you have z plus x squared all over x. You know we divided through by x cubed minus z plus x squared all squared all over x raised to power 3 is equal to, if I divide x raised to power 4 by x raised to power 3, I will have what? 2x. I'll just have only x. So you must notice that x cannot be 0 for me to have divided by x raised to power 3. So moving forward, we just simplify this equation easily. You can see if I subtract 2x from both sides, this goes and this goes, so it will be 0 remaining here. Okay, just observe that. So what do we have? We have dz by dx plus, you see I've removed this now. I have z over x plus, this will cancel out, I have just x. Okay, minus, so I'm going to open that out and have z squared plus 2zx squared plus x raised to power 4 all over what? X cubed. This is going to give me what? 0. I subtracted 2x from both sides. Now that we are here, we are close to getting to a Bernoulli equation. So we have dz by dx plus z over x plus x minus z squared over x cubed. You see that this minus is outside everything, so I'm still going to be writing a minus 2z. You see that this will cancel this and it will remain only 1x down there, so that will give me z over x minus x is equal to 0. Why is it minus x? Because I divided this by this and I'm left with just 1x there. 4 minus 3 is 1. So okay, so that is equal to 0. And what do we have next? We have, notice that this and this are similar, so I'll just say this minus this, and that will give me what? dz by dx, right, minus z over x. This and this goes, okay, x minus x is 0, and we're left with what? Minus z squared over x cubed is equals to 0. I think that this is a Bernoulli equation, but for you to see it, I'm going to put it in the standard form. In your mind, assume that z is y so that you can see it clearly. So this is going to give me what? Z prime minus 1 over xz is equal to, so I'm taking this to this other side, so that will give me what? 1 over x cubed times z squared. So this is a Bernoulli equation, and the n, the highest power of z, is what? 2. N is equal to 2. You know that what? X cannot be 0. You said it before because we divided through by x. Okay, so this is a Bernoulli equation. Now that we have seen this, we just need to what? Substitute what Bernoulli said we should substitute, which is what? W is equal to y raised to power 1 minus n. So let's substitute that. Substituting that w, so let w be equals to z raised to power 1 minus n. This is what? Z raised to power 1 minus 2, and this is z raised to power minus 1. Okay, we are supposed to differentiate w with respect to x. So what do we have? dw by dx is equal to, you remember that z is a function of x, right? So you have what? Differentiate that dz by dx. So if I differentiate, I have minus z raised to power minus 2 dz by dx. What's the next thing? We know what our w is. We need to know what dz is and what z is, okay? This implies that z is equal to w inverse. See it from here. Z is w inverse. And what is dz by dx? Dz by dx is simply gotten by multiplying both sides by minus z raised to power 2. Or you could just say divide by this, okay? Let's just divide by that. I think it's easier for us. So we have this is equal to minus 1 over z raised to power minus 2 dw by dx. If you look at this very well, this can go up. This implies that dz by dx is equal to minus z squared dw by dx. But what was our Bernoulli equation? We have what? Z prime minus 1 over xz is equals to 1 over x cubed z squared. Anywhere I see z prime, that's the z by dx, I will put what? This thing. And anywhere I see z, I'll put this. Minus z squared dw by dx minus 1 over x w inverse is equal to 1 over x cubed. My z is what? W inverse. I'm going to square it. I quickly have w raised to power minus 2. We are still seeing z, and z is w inverse. So we have minus w inverse squared. That's raised to power minus 2 dw by dx minus 1 over x w inverse is equal to 1 over x cubed w raised to power minus 2. So multiplying through by minus w squared, we have what? I just want this to become 1, okay? So we have what? dw by dx plus, because minus times minus becomes plus, and multiplying by w minus w squared. Just keep this in mind. So this becomes plus 1 over x remains the same. So w squared times w raised to power minus 1 is actually w is equal to 1 over x cubed times minus w squared. This minus must be there, right? W raised to power minus 2 times w squared is actually 1, because 2 minus 2 will give you 0. W raised to power 0 will give you what? 1. So if you look at this equation very well, this is what's linear. Here this is our p of x and this is our q of x. So I'm just going to be multiplying by the integrating factor and then solve the equation, okay? So we are going to just go straight to solving this linear equation. I wanted to stop here. I'm thinking you can solve it, but I think I still have time, so let's move and solve it. Our integrating factor is equals to exponential integral of 1 over x dx, because it's p of x. This is equal to x. We have dw by dx times x plus w is equal, multiplying by x, minus 1 over x squared. So I'm faced to solving this linear equation. This side is equal to xw prime. How do we see this? Differentiate this. We have xw prime
plus w,
which is the same as this, is equal to minus 1 over x squared. So I'm left with solving this, integrating both sides. Let's simplify before integrating. We have the xw multiplying both sides by dx is equal to what? Minus the x over x squared. I can now integrate. and it will give me what? xw is equals to minus integral of dx over x squared. This is actually minus what? Integral of x raised to the power minus 2 dx. I just did this so that it will be easy to see what we are doing. So we add 1 to the power and divide by our new power. So xw is equal to minus the integral becomes x raised to the power minus 1 over minus 1 plus c. So this cancels out. We have xw is equals to x inverse plus c. So I'm going to divide. So we make w the subject of formula. We have w is equals to x raised to the power minus 2 plus c times x raised to the power minus 1. I just multiplied it by x raised to the power minus 1. Okay, so this is actually 1 over x squared plus c over x. Okay, so this implies that w is equal to LCM is x squared, 1 plus cx over x squared. So I'm going to substitute what w is. What is w? Remember from before when we substituted in Bernoulli equation, w was z inverse, right? W was equal to z inverse. So we are going to substitute it back here. This implies that z inverse is equal to 1 plus cx over x squared. And what does this imply? I'm just going to get the inverse of both sides. I have z is equal to x squared over 1 plus cx. But what is z? From our Riccati equation, we substituted z is equal to y minus x squared. So z is equal to y minus x squared, right? Is equal to x squared over 1 plus cx. You can choose to take this as your final answer, or you get the explicit solution. So I'm going to stop here for this video. This video was rushed. I'm so sorry about how I rushed this video, although I enjoyed myself. So if you like this video, please give me a thumbs up. Please subscribe to my channel. Request for videos. I'll be glad to do them when I have the chance. Okay, thank you for watching. I really appreciate your view. Thank you.